Yes, you are right that when two forces are equal in magnitude or size, right? Either you can use a word size or a magnitude, right? Or a quantity of force, okay? But you should not use a quantity of force. But in order to understand what magnitude is, you can say yes, quantity, okay? But magnitude is a technical term, right? Magnitude or a size of the force are same, are equal, and opposite in direction. Opposite in direction. Opposite in direction. That means that they both are exerting on the same point or a same body. Okay, but they are in opposite direction. Okay.
Yes.
For example, uh, I have uh, I have taken one block here, and on this block, two forces are acting. One force is coming from right side to the left, and one force is coming from left to the right. Okay, and the magnitude that I have written here, that is 2 Newton, right? 2 Newton,
Mm.
2 Newton to the left and 2 Newton to the right. uh, that means F1 equal to F2. Okay, F1 is equal to F2. I'm calling it one force F1 and another force F2. Right now, what
Mm.
I have done here is in order to differentiate between these two forces with respect to direction, because both are equal in magnitude but opposite in direction. So in order to differentiate in the terms of direction, we use a negative sign or a opposite sign, right? If you have taken one negative force, then other has to be a positive force, or if you have taken a positive force, then other has to be a negative, right? Similarly, negative sign, I have written this here. Negative sign shows the direction opposite to the other force, right? All right. So what I have done here, since we have understood the concept of resultant force, RF, right? Resultant force is denoting resultant force. RF is showing the resultant force. Okay. So resultant force is sum of all forces. That means you are going to add all forces together. So what I have done here is F1 plus F2. Now I'm going to plug the values. F1, since we know that 2 Newton is F1 and F2 is minus 2 Newton. So I'm going to replace this F2 with the minus 2. Is this clear? Right? So
Mm.
now this plus minus becomes minus, and then 2 minus 2 is going to be 0 Newton. Now, after getting this value, after getting 0 Newton, what we can predict? We can predict that there are two conditions. Either the object has to be at rest, right? Either object has to be at rest, or if it is moving, it has to move with the same speed. It cannot change its speed. Remember, we discussed in one of the classes that there's the effect of force that can change the speed, right? You remember?
Yes. Yes.
Okay. So force can change the speed, can change the speed. So what is that force? That is the unbalanced force. You remember unbalanced force? I have discussed this here.
Yes.
Okay. So now I'm going to, repeat this, and I'm going to apply it here where the forces are unbalanced. If the forces are unbalanced, then the object has to move with a different speed, or it will accelerate. It will be accelerated. But when the forces are balanced, that means equal in magnitude, and object has either an object has to be at rest, or if it is moving, it has to move with the same speed or a constant speed. So you can, see a different terms being used here, same speed or a constant speed. Yes, are you getting my point?
Yes.
Okay, so let me find one simulation. If it is possible for me to share with you right now, give me a minute. So I will be showing you how the object moves with the same speed when the constant forces are, being applied. Meanwhile, I would like to give you one question. Uh, You have one block here, right? And some forces are acting on it. Let's say this is 2 Newton, and let's say this is uh, 4 Newton, right? And let's say this is 6 Newton. Now, can you find the resultant force now? Okay. Meanwhile, you are going to solve this one. Okay. Is this visible?
Yes.
Okay. Yes. Have you done?
Yes.
All right. Okay. So what is the answer?
0 Newton.
0 Newton. Okay. All right. Okay. Because two different forces from the right side to are acting, right? That is
Hmm.
one is 2 Newton and one is 4 Newton, right? And from the other side, 6 Newton force is acting. So that will make 0 Newton. Okay. So what will happen? Will the object be at rest, or could it be another condition?
It could also be in another condition. Like
Yes.
it
Yes.
would move in a constant speed.
Yes, with a constant speed or a same speed. Now I am going to show you one simulation where we can, perform and see that what is happening when a constant force is applied. Okay. Uh, I'm going to apply a force. Now I'm increasing the force, and you can see the speedometer here. Yes, speedometer
Yes.
here. If I am increasing the force, see the speed is also increasing. Yes. If I leave
Yes.
the force, see the speed has become constant. The object is
Hmm.
moving with a constant speed, and net force is 0 Newton, right? Net force is 0 Newton. Why? With the forward force and the backward force has become equal. The now the body, whatever the forces that was stored in the body, right? They tend to move the body for a particular of time, right? Okay, is this clear? Okay. But
Yes.
due to inertia, and due to, sorry, friction, due to opposite forces like drag or air resistance, right? So that could make the body stopped. Is this clear? Okay.
Yes.
Okay. Let me do perform it again. I'm going to uh, I'm going to apply force. Right now you can see there's 0 Newton. Now I'm increasing force. What is the force that is acting? What is the value, beta? You can see 94 Newton here.
94 Newton.
Yes, I'm increasing now. It is 117 Newton. Okay.
Yes.
A constant unbalanced force is acting. Yes,
Hmm.
unbalanced force is acting. ठीक है, वो बच्चे को तो गया, इतनी फोर्स लगा ही नहीं सकता था अब तो। चलो, गुड हो गया ये।
Hmm.
ठीक है, let's perform it again. Now I am applying 54 Newton. ठीक है, let me see the speed as well. ठीक है, I'm increasing the force. I'm increasing the force. It's 139 Newton. ठीक है, the speed is also increasing. Now, if I leave the force, so the body will tend to move with the same speed. Now, is this clear?
Hmm.
ठीक है,
Yes.
बट ये सारी जिंदगी के लिए नहीं होगा, ठीक है, इट विल नॉट कंटिन्यू इट्स मोशन, ठीक है, अनलेस देयर देयर शुड बी अपोजिट फोर्स, ठीक है। यहाँ पे तब तक ये होगा, ये जाके रुक जाएगा, ठीक है, द टाइम विल कम, ठीक है, इट विल बी स्टॉप्ड व्हेन द एयर रेजिस्टेंस आर गोइंग टू एक्ट ऑन इट, और अपोजिट फोर्स और अ फ्रिक्शन इज गोइंग टू एक्ट ऑन इट, राइट? ठीक है,
Hmm.
but you just need to understand whenever forces are balanced, either object will be at rest or it will move with the same speed. Okay, so let's see. Um, Now over here you can see the right force is greater than the left force. So if I
Hmm.
want to increase the left force, now have they become equal? ठीक है,
Yes.
ठीक है, अभी भी ये राइट पे जा रहा है, यहाँ पे एरर है बिल्कुल। ठीक है, चलो अब देखते हैं। नाउ व्हाट इज हैपनिंग?
It's the forces.
यस,
It's not moving.
it's not moving. That means the forces are balanced. Is this clear? So
Hmm.
I have shown you both conditions. Either the object will move at the same speed or it will move um with a
One.
different speed, but sorry, with the same speed. ठीक है, either the object will be at rest or move with the same speed, right? Now, if I
Hmm.
increase force from the right side, okay, what is going to happen? The trolley will have to move to the right side. Yes,
Yes.
okay. Now see, unbalanced force is acting. That's why the speed is also
Yes.
increasing. Okay, okay, beta. So you can perform this. I'm going to paste this link in the chat box so you can later perform it. सही है। और ये वाला भी कर सकते हैं आप, ये लिंक भी देख लें, ठीक है। इसके अंदर भी हम देखो, नेट फोर्स इज 0 न्यूटन, बट द ऑब्जेक्ट इज मूविंग विद द कांस्टेंट स्पीड दैट इज -48 मीटर पर सेकेंड। लेट मी इंक्रीज द फोर्स टू द राइट साइड। नाउ सी, अब देखें आप,
Hmm.
ठीक है। I have increased the force towards
Yes.
the right side. Now the object is moving to the right side with a increasing speed. Yes. Here the word is used
Hmm.
velocity. So for this time you can just relate velocity as a speed, but there is a difference between the velocity and speed. Okay. Now the object is moving with a different speed. Yes, it is speeding up, right? Now
Hmm.
if I'm going to decrease the force and if I balance the forces, now still the object is moving with the is moving but having same speed. Is this clear? Is this clear now?
Yes.
ठीक है, चलें। So let me take this link and paste it in the chat box so you can later, आप इसको कॉपी कर लें अपने पास, ठीक है। All right, so let's back to the hmm. So I hope the concept of balance and unbalanced forces are clear. Okay.
Yes.
Now, in the same way, we were dealing with the horizontal forces, right? Okay. ये इस तरह हम forces की बात कर रहे थे horizontally. Now, if we talk about the vertical forces, right? So, a contact force and a weight. ठीक है, if the object is placed on the table or on a ground, right? So the upward force, we call it a normal force or a
Normal.
contact force, and we label it with the C, capital C. We use a capital C, right? And for the downward
Hmm.
force is because of the strength of gravity. Okay, so that is the weight. Okay, so the force
Hmm.
that is exerting downward, okay, it's the weight of the body. Okay, so this time also you can say and you can observe both forces are being balanced, right? आपका जी C और W जो है वो दोनों क्या हो रहा है बेटा, बैलेंस हो रहा है, that's why
Balance.
RF is going to become 0. Is this clear? It's a balanced one. So object is not sinking. What should I say? The object is not sinking. Sinking means that it is not going down. Okay,
Yes.
got it? So now you can see here which arrow is larger, the C1 or W1?
W.
W1, right? So I can say W is greater than C. That means weight is greater
Hmm.
than the contact force or a normal force, right? So
Yes.
if the car is on the muddy surface, okay. So I have taken all right, say muddy surface. So the car is going to sink as weight is larger than the contact force. Okay, that makes
Yes.
sense, and uh, it's a very easy concept. After that, we have I have considered the total weight of the car, that is 8,000 Newton. Okay. So how much force is needed to lift the car or to balance the car? So how much force is needed? If the weight is 8,000, so how much force is needed to lift up or to balance the car? Yes.
Um.
In order to balance it, beta, we have to have the 8,000 Newton. ठीक है, अगर
Hmm.
डाउनवर्ड फोर्स 8,000 है तो अपवर्ड फोर्स भी तो 8,000 होनी चाहिए ना. क्लियर हो
Yes.
गया? ठीक है. और greater than the 8,000. ठीक है. Now again here's another question. I have taken up, what is the force acting on each tire? How many tires are there in the car? Four,
4.
right? One, two, three, four. अब ये 4 टायर्स हैं इसके, और इसको आप 8,000 को 4 से डिवाइड कर देंगे तो यू विल गेट 2,000 न्यूटन
2000.
on each tire. And you have to define the direction, right? Direction is downward. Since we are talking about the weight, that's why we have to specify the direction as well. Remember, forces are always acting.
Hmm.
Forces always act in pairs. ये बात आप याद रखिएगा, पेयर्स में होती हैं हमेशा फोर्सेस. ठीक है. हमने राइट और लेफ्ट की
Yes.
बात की, हमने अप एंड डाउन की बात की है, राइट. सिमिलरली हमें फोर्स की डायरेक्शन भी हमें बतानी होती है. रिमेंबर दिस थिंग. ओके, वी हैव टू डिफाइन दैट डायरेक्शन. ठीक है, right? Either the object is moving
Yes.
right side or left side. Okay. So if the force that is 2,000 Newton is acting on each tire, so it will be downward as well. ठीक है, हमें ये भी बताना होगा कि उसकी डायरेक्शन कहाँ है. मैग्नीट्यूड तो हमने बता दिया ना. ठीक है.
Hmm.
So what is magnitude here? In 2,000 Newton, in 2,000 Newton downward. So I hope that you have got this thing कि आपका ये जो 2,000 है ना, आपका 2,000 है, this is the magnitude. Okay.
Yes.
And here's the n is a unit, and the downward
Hmm.
is the direction. So is specified force is specified with 3 things. Magnitude, force is specified with 3 things, right?
Yes.
All right, so force is specified with magnitude, unit,
Unit.
and
Direction.
direction. And forces always act in pairs. Okay, हमेशा पेयर में होती हैं. Forces always act in pairs. ठीक है. I hope this is clear to you. And now the new topic that we started in the last class, that was formation of solar system. Okay. So I think before that we should do some past paper questions related to mass with gravity. So here's the question. An object has a mass of 50 kilogram. The gravitational field strength, that is G, right? Gravity.
Hmm.
Okay. Or strength of gravity on Earth is 10 Newton per kg. So gravitational field
Hmm.
strength on a distant planet, okay, that is unknown to us. there's another planet which is not labeled here. So on a distant planet is 4 Newton per kilogram, right? So what is the weight
Yes.
of the object on Earth, and what it is its weight on the distant planet? Now you can recall I discussed this point, ठीक है, कि जहाँ पे ग्रेविटी कम होगी द वेट इज गोइंग टू लेस, एंड जहाँ पे ग्रेविटी आपकी स्ट्रेंथ ऑफ ग्रेविटी ज्यादा होगी वहाँ
Yes.
वेट इज गोइंग टू बी ग्रेटेस्ट, राइट? ठीक है, सो ऑन द
Yes.
बेसिस ऑफ दैट अंडरस्टैंडिंग, ऑन दैट कॉन्सेप्ट यू कैन आंसर दिस क्वेश्चन, राइट? सो व्हाट शुड बी द आंसर बेटा? इसका मास कितना है?
Um,
यस, मास इज 50
uh,
किलोग्राम.
no, mass is 50 kilograms, and the weight on Earth would be 500 Newton.
So if I say strength of gravity on Earth is 10 Newton per kilogram.
Hmm.
Okay. So if I find the weight, so it's going to be W is equals to mg. So you have to first of all define the formula as well. Okay. Sometimes they set the marks for writing the formula as well. Okay. Okay. Mass multiplied with strength of gravity. So mass is 50 kilogram multiplied by 10 Newton. It's going to be 500 Newton, right?
Yes.
Okay. So it's the weight on Earth. Now, as we know that mass remains constant everywhere, so it's going to be the same on a distant planet. तो वो भी
Hmm.
आपका 50 kg ही होगा, और
Yes.
distant planet पे आपका जो strength of gravity it is given here 4
4
Newton
Newton
per
per
kilogram,
kilogram.
and the similar formula is going to be used. तो
And then
आपने क्या करना है,
200,
50 multiplied by 4, so it's 400. Oh, sorry, it's 200, right?
200.
200. Clear? A simple
Yes.
calculations are involved, right? So now on Earth it's 500 Newton, and on distant planet it's 200 Newton. So it's D, right? Similarly, question number 2: an astronaut in an orbiting spacecraft experiences a force due to gravity. Okay, read the question. The force is less than. The force is less than. Which force? Experience the force of gravity. Force of gravity, right? ठीक है? The force is less than when she is on Earth's surface. जब वो Earth पर थी और वो किसी और is इज ऑर्बिटिंग, ठीक है, तो जहां पे वो ऑर्बिट कर रही थी वहां पे फोर्स क्या है, कम है, और अर्थ पे फोर्स ज्यादा है, राइट? सो कैन वी से कि आपके ग्रेविटी ऑन दैट ऑर्बिट, ठीक है, इज लेसर, सॉरी, इज लेसर देन ग्रेविटी ऑन अर्थ, ऐसे ही, यानी अर्थ पे
Yes.
ज्यादा है. Are you getting my point? This force is less than when she is on the Earth's surface. So compared with being on the Earth's surface, how do her mass and her weight? A mass remains constant everywhere, ठीक है? So mass remains unchanged, ठीक है? So either the C option or D option, right? या तो C होगा या D
Yes.
होगा, because mass के कॉलम में आप देखो अनचेंज कहाँ पे आ
Yes.
रहा है, C और D में आ रहा है. Now you are going to decide from the weight. वेट कॉलम में अब क्या होगा, वेट इन ऑर्बिट, जहाँ पे उसका वेट, जहाँ पे ग्रेविटी कम है वहां पे वेट भी कम हो जाएगा, जहाँ ग्रेविटी ज्यादा है
Yes.
वहां पे वेट ज्यादा हो जाएगा. इस इज क्लियर? ठीक है. सो
Yes.
वेट इन ऑर्बिट, ऑर्बिट के अंदर वेट क्या होगा उसका, ऑर्बिट के अंदर जो फोर्स है वो क्या है, कम है ज्यादा है?
Comment.
कम है. सो दैट मीन्स वेट इन ऑर्बिट इज गोइंग टू बी डिक्रीज्ड. सो विच शुड बी द
Yes.
करेक्ट आंसर? The C1.
Because-
Okay. So there are more couple of questions I would like to give you. So inshallah after the class I'll be sending you. Okay. Right.
Yes.
Okay. Allah Hafiz. Assalamu alaikum.